Okay, good morning to everyone. So first of all, thank you for being here. I really appreciate it. And well, for me, it's a really good honor and also a very good opportunity to present a little bit of my work. I promise that I'm not going to be too technical. It is a little bit of different, my presentation from prior ones, but I'm going to give a little bit of context of what I have been working on using Blockly, which is a technology that I've been somehow exploring for 4 to 5 years now. So what I'm going to talk about is the usage of blocks for CS undergrad programs, and especially from a computer science education perspective. So I'm going to introduce some of my experience working with block-based environments for data structure courses. My name is Pedro Guillermo Feijóo-García. I come from Colombia. I am an assistant professor at Universidad El Bosque in Bogotá, and currently I'm doing my Ph.D. in human-centered computing at the University of Florida in Gainesville. So, well, the first thing to address is what is happening when it comes to talk about blocks and computer science education. So we have a different set of venues. I don't know if, or maybe yes, maybe no, some of you are aware of SIGSI, of EDC, ICER. There is a bunch of people from education colleges, from computer science colleges, for human-computer interaction colleges, working in the use and in the extension of blocks for different contexts. It is very common to find contexts as K-12 commonly addressed by people when it comes to the research community. So we get to have people referring to elementary school students. We get to find people referring to CS plus X. We get to find people referring to high school, and that's very common. A little bit less common is finding people referring to Computer Science 0 and Computer Science 1 courses when it comes to talk about CS curricula. I say less common because we have a vast amount of work of people working using Scratch, using Alice, using pencil code when it comes to talk about introducing people to programming, but still it is less common than talking about K-12. That's kind of like the trending when it comes to talk about these kind of technologies. Something that I came to think was, okay, if we have CS0, if we have CS1, if we have K-12, what is the reason why of not using blocks in other kind of computer science courses that we get to have? So it is something that is interesting because especially when it comes to talk about courses like data structures that are the subsequent ones to Computer Science 0, Computer Science 1, we do find researchers telling that the literature when it comes to talk about data structure courses, for example, is still infant, is still not there. And we're talking about people that have tried to understand what is happening to the students when it comes to already complete Computer Science 0, Computer Science 1, Computer Science 2 courses, and to get to upper level courses in the computer science curriculum. So this comes with a little bit of my anecdote. When I started teaching data structures at Universidad El Bosque, Universidad El Bosque is a university in Colombia, and in Colombia we don't speak English as a first language. Our first language is Spanish, and even if we understand that English is something that is common in the world, it is not that common when it comes to live in other kind of countries. So I got one particular student that he was struggling very much understanding the data structure. He was struggling understanding the literature, and I had a platform. Well, it's not a platform, it's more like an environment built using Blockly, but it was for elementary school students. His name is Roblox, and I gave this student the opportunity to complement the learning process using my platform or my environment for the idea of the course. So it was working using blocks and trying to find somehow a little bit of connection and working with the block environment. Something that I found really interesting was that the student did like working with blocks, and apart from it, the student started working better in the idea of the course. So that's something that got me to read, got me to try to see, okay, how many people, at least in the computer science education research community, how many researchers are actually trying to understand or trying to bring the idea of blocks or visualization when it comes to talk about computer science upper courses. So I found that there were not so many. It's like actually there are really few people working with blocks when it comes to upper level courses. So that brought me to the question is like, why not using blocks for data structures? That was the first course that somehow I was addressing. And something that I found really interesting is that, yes, I'm pretty sure you're aware that when we work with Blockly, and when we get to work with blocks, we're able not only to visualize, but we're able to visualize what we make. So it's like a dynamic and a live feedback that we get to have. And that's something that is very particular of these kind of technologies. When it comes to building a data structure using a programming language, a traditional textual one, well, the person needs first to conceptualize. And apart from the conceptualization, it comes the process of building the technology or building the data structure or building it, and then the testing process. Everything takes like a whole track of sequence tasks that is not immediate. And when the student doesn't find a right solution, what happens is that the student gets to struggle, and that can lead to frustration. So that's something that made me to think, okay, what if we have blocks programming in this kind of context scenarios, and we get to bring to the student the possibility to make, visualize, and understand a concept lively. So this is the very big issue behind this presentation. I'm going to present to you two technologies that I have piloted. And the idea is, well, how do we get to incorporate Blockly with all the different set of technologies? And how do we get to evaluate, and how do we get to find somehow the role of blocks programming when it comes to talk about data structure courses? So we began with linear data structures, and this first project was named DStBlocks. Yeah, data structure blocks. I know the name is not trending at all. It was funny how we came for that name, but yeah. So the environment was designed for linear data structures, and it was the idea to work with stacks, with queues, with simply linked lists, and with doubly linked lists. At the very beginning, we were a little bit of ambitious, and we tried maybe to extend it for hierarchical data structures and maybe thinking about the graph. But at the very beginning, we were like, yeah, we're going to keep linear. The context language was in Spanish. It was addressed for students at El Bosque University and also at Los Andes University, both in Bogotá, Colombia. And the main concept was to let the student create, view, modify the data structure at the same time, and using a block-based approach. So this is, give me one right there. So we can see it there. Can I use this one? Okay. Okay. Okay, yeah. So something that is particular from this approach is that when you find the demos, when you find the technologies using Blockly, it happens that the demos get to present generally a canvas and get to present the canvas that we get to use to drag and drop, yes? The first thing that we were thinking was, okay, when it comes to talk about Blockly, what are we supposed to present to the student? How should the data structure appear? How should the data structure be somehow visualized? So it was funny because at the very beginning, for example, we are presenting the data structure here, but at the very beginning, we were having constraints thinking, okay, where are we going to place it and how are we supposed to do so? So we have an iterative process, and the iterative process was more centered, okay, how are we going to represent the blocks? How big are we going to have the canvas? How many blocks are we going to offer? And that was working for this. Here, what we find is a set of functions, and the functions were specified working just in one solely class for this particular solution. And we were really into Blockly is perfect at that point. So we were not addressing like Blockly has design or aspects that we need to check, double check, modify. But what we were trying was like, okay, what is the incorporation of Blockly with a different set of technologies going to impact when it comes to the learning and the user experience design outcomes? So let me just move it a little bit farther here. Yes, right there. Right there. Right there. So what we were offering was a chance of, okay, here we're working with a simply linked list, and the idea was like, okay, based on what the student is included here, what the student is somehow creating, we get to have feedback here. And the feedback was based in the backend having a real data structure that should work, and the data structure that the student was somehow building. So that was the way that we were connecting. And backend, that was the way that we were somehow matching the response from the student to what was expected. In this pilot, something that was really interesting, I'm going to show you later, is that when it comes to talk about the data structure, the student did find interest in the way the data structure was presented. And something that we also got, for example, to check was the usage of the colors when it comes to work with this. And also something that we got to work was, okay, how are we going to represent the flow of the different actions and the different sections that are happening within the blocks. So that was the first technology, is DStBlocks. And well, coming back to this, so as I told you, we didn't make big extensions to Blockly. Yeah, actually, I think we didn't make any extension at all, differently from what most of you have presented here, and I apologize with that. But something that I like of Blockly is the idea of using it as a component that is versatile and that you can adapt and you can manage in a way that I really appreciate it. Really, that's something that I was telling yesterday. It is really interesting to find such a tool that is so versatile that you can adapt, you can work with it. What we do in this particular technology, what we did was using Blockly in addition to Vis.js, that is a library, that is the library that let us represent graphically the data structure. It was web-based. Yeah, we have another set and bunch of requirements referring to user login, logout, how we're going to manage the profiles, how we're going to be able as instructor to see the solution a student is providing. That's a part, but when it comes to talk about Blockly and Vis, that was the connection that we made in order to make possible the visualization. So something that we got to have, and this is something that I want to present here, is that when it comes to talk about the functions, in the function, something that happened, and that was something that somehow we tried to manage and to restrain, was how do we make, or how do we put possible the variable that we're going to use, for example, in an insertion, how do we get to make the student understand that in the context of the data structure, you need to insert just one element. The idea is not passing one more parameter, and trying to restrain a little bit that. So that was also something that we got somehow to work on when doing this technology. So it happened in two sets of evaluations. This was a first pilot study that we got to happen in fall 2017 and spring 2018. It happened in Colombia in two universities. We got at the first pilot, the first usability testing, we got 26 participants. It was not that easy to recruit people. That's something that I regret back then, but still, it was interesting how they interacted, they worked with it. And the idea was not somehow to jeopardize the process of them taking other classes and all. It was for computer science major students. And in that particular phase one, we worked with students that had already taken computer science courses on data structures. What was the reason why we did this? So what happened with the usability test in phase one was that students were already somehow biased with traditional programming languages that they were using before. Yes. So this is something that I can show you later. The papers, due to time, I'm not going to present the phase one. I'm going to go directly to phase two. But what happens in this one is that we wanted to know, particularly for the students that had already taken data structure courses and had already experienced programming a data structure using a traditional language, what was the experience of them working with blocks? So that was something that somehow we use not only to find like the meaning or the reason why we needed to keep working the project, but also to identify, okay, what are the design issues or the design aspects that we need to improve for a second version. So for the second version, we did get to work with participants from both universities that didn't have, on this one, there's a small typo, didn't have knowledge of data structures. Yes, so this one was the second one, and we were working with participants with no prior knowledge on data structures. And what we did in this second phase was having a pre-test, a post-test. They had an activity working with the technology, working with blocks, and the idea was working in one particular data structure, understanding it conceptually and practically, and doing the whole activity first with blocks, then with text, and then getting to self-report and present how was their experience and how was their perspective. When it comes to the pre and the post test, what we tried was to, okay, the student first needed to explain the data structure, and then the student needed to explain one of the operations with the data structure. So there were two questions, there were open questions that we analyzed, and we applied somehow like a Likert scale to both. And the idea was, okay, let's match how much the student somehow improves or get worse when it comes to interacting with the tool. So it's right here. We got a very interesting distribution. When it comes to talk about the first question distribution and referring to the data structure, in the pre-test at the very beginning, we had a lot of students that had no idea of the data structure. When they came to explain the data structure, when it came to explain the concept, the students, well, they mostly said, I don't know, yeah? Or they tried to address it in a way that's like trying to explain something that they didn't know. And it was interesting. So it was something that happened for the first question. Right after interacting with the tool and fulfilling the activity was an activity, a homework assignment. They had to work with the tool. We had logs and all of showing their interaction. And right after that, what we found is that participants moved from not having idea or having very, very low idea on how to work with the data structure to actually fully explain the data structure and give examples from it, or to barely describe the data structure, but giving proper example. That was something that happened after interacting with DStBlocks, and we were really happy of that one, especially on the understanding on the concept, because that's the idea like that. For the second question was mostly addressing the operation. It could happen in zero code. It could happen explaining how to add it, like step by step. Or there were some other students that they were directly trying to code it using one programming language that they were used to. And at the pre-assessment, something that happened is that we didn't have any participant able to understand the data structure operation with no coding errors. So it happened that at the very beginning, the people that tried to address it were very few, and apart from being very few, they did present errors, and well, it was something that we observed from this pilot study. When it came to talk about the post-assessment, after interacting with the tool and fulfilling the assignment using DStBlocks, it happened that we stopped having learners that didn't understand at all the data structure operation. And we did have students that even after interacting with blocks, that was something interesting, they tried to address using coding. And it was cool to see that after interacting with the tool, yeah, they got to have some syntax errors, they got to have issues referring to syntax, but mostly the operations was something that happened to be mostly accurate. And we happened to have, it was one participant that was able to fulfill and to respond to the operation completely. So that was something that happened for this study. When it comes to the self-perceptions, and this is something that I want to present, because sometimes we forget that when we build technology and when we have technology happening, there is a user, there is somebody that is behind, and it is interesting to see that it is not only kids when the ones that get to tell like, yeah, I like blocks programming, I like the figures, I like the geometry, I like the colors, but actually that we get to have CS students that have already experienced programming languages telling, yes, I find useful and I find highly useful using, for example, technology like DStBlocks to learn data structures. That's something that is really interesting, especially for that like understanding that we have in community of practice, that we need like to be root when it comes to teaching computer science. And no, it is something that happens here, and that we find really interesting, is to have students telling us, yeah, I did like working with blocks for data structures. Also something that happened, and this is like a very big pilot one, was that when we asked how clear did they consider the data structure visual representation was, well, we find a lot of people telling that it was clear, people telling that it was very clear. But now looking at it back from this, and this is something that's the reason why I told before, we didn't address Blockly particularly, but we addressed the technology using Blockly. We didn't get to ask about affordances and interaction aspects happening with the block-based environment working with the data structure. So that's something that is still in the process, like to get to think, and I'm going to explain further. So we got very good participation responses from our participants for this first pilot that was for linear data structures. So it was well received by the target population, yes. And right after, well, we kept thinking, okay, it worked for linear data structures, but linear data structures are something that is still happening in computer science 1, computer science 2 courses. So what if we get to think about blocks for other kind of scenarios? So that led us to working on blocks for DS, that is the second somehow system or prototype system that I have been working on with my teams. So this second system happened in the University of Florida, and it happened with a group of people, really smart people, really engaging people working from computer science, human-computer interaction perspective. Something that changed here is, well, the context of language happened to be in English. Yeah, I wanted it to be Spanish, but I don't know. It's interesting. And well, something that changed also from the first approach to the second is further representation of different classes happening backend. I'm going to show it later with a UML class diagram that we have somehow representing the data structure that we model with blocks for DS. And also something that happened differently is that working for DStBlocks, everything was iterative. So we had the for, we have the while, and the students were interacting with it. Right here, the idea was to work using recursion, and the idea was to bring recursion as something to happen in the environment. So again, the concept is to let the student create, view, and modify the data structure at the same time. And in this case, we work for the binary search tree as the data structure to model. Again, the technologies were the very same. We had VSGS, we had Blockly happening, and it was mostly web. So let me show you right here. So if we get to see here something that happens, and I'm going to explain further because this happened in an iterative process of design for blocks for DS, is that we get to have a menu that is a little bit more extensive than the one that we had before in DStBlocks. At the very beginning, the first prototype that we have for blocks for DS, it was named before blocks for Gators, yeah, because we are very proud Gators in UF. It happened that we only had very few items in the menu. We had very few elements for the student to pick, and we tried to condense everything. Doing some cognitive walkthroughs and doing them informally and some of them a little bit more formally, we happened to find that the students that were interested with the tool, they did find difficult to identify the different blocks due to color, yeah, due to the location. So we start playing, okay, how are we supposed to present the menu in a way for the student to be able to drag and drop in the best way possible the blocks that are necessary to fulfill an operation. So we get to have integrated core functions that are for debugging. That was something that we didn't have before for blocks for Gators, and students were like crazy saying, why I don't have a block that is letting me add immediately an element to the binary search tree? Why do I have to implement the whole insertion operation to get the binary search tree work? So it was the first one that we included right here. And we got to specify different menus and submenus working with functions on the tree, functions on the node, and also referring to different set of functionalities happening in the tree and in the node. So we have actions in the tree referring to the number of elements, for example, referring to the root node, and also working at the node, referring to getting, assigning, querying, and responding information with blocks. All the blocks happen to be attached to the UML class diagram that I'm going to present after. Actually, let me move it right here so that you get to see it tested. Right there. Yeah. So all the blocks happen to respond to the UML class diagram, and what we tried to have was the very same approach backend. We had a data structure working correctly. It was the data structure that we were supposed somehow to have perfectly, and another data structure that is the one that the student is trying to match, and we make the comparison between both. So again, we use VSGS for the representation here, and the idea is that the student gets to play in a way that he or she's going to be able to visualize the data structure while building in, and also getting to find, well, aspects coming from the code. Something that I want to show here, right there. If you get to see, we have blocks, for example, referring to the particular operations on the data structure. So we have insert element to node, receiving a node as a parameter and an element. We get to have, for example, questions referring to gets node element, assign, or even we have questions as, has this node a right node? So those are questions that came interacting with the students in order to see, okay, what are the questions, what are the actions that you are looking to have when it comes to work with the data structure? Yes. So it was something that was really interesting. And well, we got the prototype and we got some kind of good pilot results that I'm going to present right after. as I told you, we had a different set of menus and items and all happening here. And this was the structure that we had backend. It's a very simple structure, but every functionality, every getter, every setter, every action requirement that we have there in that UML class diagram is matched with a block and is represented according to the category of the functionality that we're trying to address. There. The evaluation happened in two phases too, and this one, well, it was actually one phase, but in two different perspectives. So we have a learning lens, and we had another one that is this user experience lens. For the learning lens, we had a pre and a post assessment that, if you want, I can share with you the paper. Due to the time, I can share with you the paper that presents a little bit more in detail on the pre and the post assessment and the results. And for the user experience lens, what we had was a fulfillment of a set of activities and checking the times that happen that the students somehow spent to fulfill a complete assignment using, in this case, blocks for Gatos or blocks for DS. And finally, we also had a self-perception survey that the student answered right after interacting with the tool. So we had a set of distribution referring to the interaction with blocks for DS. How easy or hard did they find the tool? And well, we had here a distribution. Two people said that it was kind of like hard, but still, if you get to see the trending, it's saying that it was kind of like easy. How well organized did they find blocks for DS, the graphical user interface? We also get to have like a positive trending from the users. And according to this, how easy was to accomplish the task using the tool for a binary search tree. So something to tell here is that we were working with computer science students of second semester freshmen with no prior experience using the binary search tree and no data structure course. It was difficult to recruit them. I can tell you that we are still in the process. We have the RB open in order to get more participants and get a little bit of better feedback. This is just a pilot study, but still it was interesting to see that working in 60 minutes, they were able somehow to achieve an understanding of the binary search tree using blocks. So that's something that we get to find here. There were participants that, yes, they already knew or vaguely knew maybe the issue was due to the test, maybe the issue was because they already knew the data structure and the filtering process was not that strict for this due to the recruitment. But still we had participants with no prior experience at the very beginning that after interacting with the tool and responding the post-assessment, they got to have a better understanding with it. And well, from the pre to the post, something that happened is that statistically, we got to have lower standard deviations and better means. So that's something that we are still in the process of finding like a better understanding of what is happening with the tool. Right there, pre and post assessment. So something that we can tell is that working in less than 60 minutes, that was the study and the participants' interaction. So working with the assignment, working with the tool, responding to the pre-post assessment, everything happened in less than 60 minutes. We got to find positive results. We got to find good feedback from the students, and we got to find somehow a good performance on this. Something that we also find here is that following a learner-centered design process favored the design of the tool, especially for the menus and for the staff. And that's something that we didn't do for DStBlocks, but for blocks for DS, it happened to happen. And it was really cool, like to find how aspects as little as modifying the menus, modifying the colors, are trying to find somehow a different set of categories for the blocks, help the students achieve better results. So this is, to conclude, blocks can definitely be used in scenarios different from K-12, CS0, and CS1. Yes, and questions like why not using blocks in upper level courses, like thinking of them for courses like operating systems, functional programming courses, or stuff happening in upper level. That's something that is a question that we need to ask, and especially for the communities on computer science education, that's a question that we need to bring. Why not having blocks in other contexts that are not just teaching basic programming? We need to conduct further research, and it is going to happen trying to be a little bit more in activity. So we're thinking about having think aloud protocol, having some kind of analysis of how the student is navigated visually, having eye tracking on how the student is navigating with the canvas, with the blocks, and how somehow the student is aiming to understand the different things that are happening in the environment. And of course, trying to address a little bit more advanced computer science concepts. Yes. Also, something that we're really into is, well, following the work of David Weintraub and following also the work of one of my colleagues at UF, Jeremiah Blanchard, is trying to understand, okay, now we're working with blocks. How should the transfer happen when it comes to work with text in these kind of scenarios? And what is happening when it comes to that transfer? So we are providing blocks for students in data structures. Now then, how should the transfer be, for example, to a programming language, say JavaScript, Python, Java, like that? How that happens and how should that happen? That's an open question that we have, because I'm into understanding how people learn. So that's it. I want to publicly acknowledge the people that have participated in these two pilots, my students and my advisor, Fernando de la Rosa, and my current advisor, Dr. Christina Gardner-McCune. I want to publicly acknowledge them for their help and their advice. So that was it. Thank you so much for this opportunity. Any question?
I was the wrong person. Okay. Actually, related to the very last thing you were talking about transferring to text-based languages, I was wondering if you got any resistance either from students or other teachers about the fact that we often hear, oh, it's not real programming because it's blocks. So anything like that?
Oh, yes, definitely. So the second part of the talk, I'm actually like giving you a spoiler of what is going to be my talk in BLACC. And this is something that it was not of like a direct colleague, but it happened that one of my peer reviewers in a conference that is on visual languages and human-centric computing happened to give me feedback telling me, why do we need to have blocks for data structures? That's something that I can perfectly do with a whiteboard. So I was like, okay, first, why are you reviewing my work if you don't trust like visual languages in a visual language conference? It was hilarious. But still, that's kind of like the perspective. And even in Colombia, that's something that I get to have the argument with my colleagues. Well, not the argument because we love each other in our university. It's a really good university. Whenever you want to visit, you're welcome. But what happens is that they get to think that when you simplify computer science, and especially computer science instruction, it's kind of like you're trying to miss something. That's kind of like the understanding. So I bring it from the Colombian perspective, and that's the reason why I start working with blocks, is because, as I told before, when it comes to programming languages, and that's also something that I'm researching. Last week, I went to a conference for a lightning talk talking about language barrier for computer science and blocks. It happens that when it comes to talk about programming languages like Java, JavaScript, when it comes to talk about Python, I can tell you, as my experience as instructor here, I don't get to have the same questions from my students. So in Colombia, it is normal to have students that they don't speak English at all. And they ask me, what is the meaning of a while? What is the meaning of for? Yes. There are words that we can somehow like translate, like public, private. But I can tell you there are a lot of words that are happening in programming languages that they are not intuitive for students. And even if you have the literature in the language of the student, still, it is difficult for them. And I was talking yesterday with colleagues here, talking about operating systems. For example, in English, mkdir is something that is direct, make directory. Yeah, you tell that to someone in Spanish, and I can tell you it's like saying, I don't know, Wingardium Leviosa, like that. Yes, because it's not strict and it's not clear. So I give the argument that, yeah, especially in my context, it is necessary to work visually, because there is a learning curve that is different from the different contexts, and especially in contexts that are not English-centric, the learning curve working with programming languages that are English-centric is still greater. So bringing blocks, bringing the affordances, bringing the colors, bringing the possibility for them to ask or refer to actions in their own language, that's necessary. And yeah, I still have people somehow like fighting back because they didn't learn that way, but times are changing. So I'm really happy for that. Thank you for your question.
All right, I'll try to go really fast because so first, I agree with you on the language thing, and we actually had 1.6 million people use App Inventor in Spanish in the last year. So it's the third most used language. English is obviously number one. Chinese is number two. So lots of people are learning programming in at least App Inventor through having translations. I'm sure it's the same with Scratch. And yes. So my actual question though is, have you considered incremental updates in your editor? Because the examples you showed, people had to rerun the entire sequence. And so in App Inventor, we have this ability to run individual blocks. And so you could just try inserting one thing and see how the tree is changing from frame 1 to frame 2. And then whether that would help people get an even deeper appreciation of the actual operations that are happening, because they can't really see the whole thing, right? Or at least it wasn't clear from the video. You just get no tree to full tree, and you're not seeing how it's actually being built. And two, have you considered follow-up studies with the students, because you queried them immediately after and their knowledge seemed pretty good, but does it actually get retained, say, a week later?
That's a really good question, and definitely yes. So we are trying to address the understanding of blocks for these kind of upper level courses in different levels of cognitive load. And that was something that I was actually talking yesterday. I'm very interested in how people get to have provenance due to interaction, due to data, the representation of data, and especially when it comes to significant learning. So what happens is that, right now we tested before, after, and that was kind of like the simple pilot study that I'm presenting here. But the idea is to understand, well, how do students actually get to resemble to the information, get to attach it? How do students actually get to learn? So if it is happening due to the drag and drop affordance, it is happening due to the geometry of the block. If it is happening due to the words that are happening, that's something that we're still, or at least my team and I, we're still not able to respond to that. Yes, we want to have a little bit more, and I have done that before in another technology that I built using Blockly, having the step-by-step. That's something that we can do with Blockly and also manage the time in a dynamic way for the users. But in this case, it happened that the interaction with Viz. So backend working with Viz.js, Viz is wonderful. Yeah, I love the library, but it was not as straightforward as we were thinking that it was going to happen. So the reason why it happened to be like an all or nothing was because of the way that we were managing the nodes graphically with the graph representation of Viz. We're still trying to address and trying to understand how to make it possible the step-by-step without jeopardizing the interaction of the user. And yeah, definitely we want to understand what is happening in the user mind when it comes to interact with blocks in this kind of context. So yes.